Cuando podemos mover la mesa.
Hope everybody made it here safely with the weather. Are we ready to record? Okay, you can go ahead and start the recording. This recording? Okay, good. All right, so yesterday we talked a little bit about the gas dryer that everybody was working on. And today I'm going to go over the actual burner and how it operates. But I got some schematic here. We're going to talk about that. We're going to talk about gas pressure testing. Talk about how this whole assembly works as far as the dryer starting up. So first of all, I just got two diagrams here. We got one diagram here showing a dryer with an electric heating element. Now, I don't know how well you're zoomed in, but if I'm using the board, if you could zoom in on that so people could see, you know, if they're watching. Because like Boone is not here today either. So we got electric heater here. And then over here, this little whole box right here, and I zoomed in so you guys can see better, is the actual gas burner assembly. Do you guys want to come over here and sit closer? Or there's plenty of chairs here. If you guys want to come around and come closer. We'll wait. You guys can all sit here. You have to sit. I know it's hard with Paul there. He's in your way and you can't see. It's all Paul's fault. All right, so we have the electric dryer and the gas dryer. With the electric dryer, we're going to have 240, we're going to have 120 volts. We use 120 for the motor, the timer, and any of the controls. The only thing we use 240 on is the heating element. And on this one, the timer does go to line 2 also. So on this dryer, one of the very few dryers, the timer motor is 220. Almost all dryers, the timer motor that moves the timer is 120. You'll know by the diagram where it comes in here and goes all the way to line 2 instead of neutral. Okay, if not, if you don't have the diagram, on the actual back of the timer it says 120. I'm not really here to talk about that. I'm here to talk about the gas. So this whole assembly is what we have right here on the table. All these parts in that little diagram right here, and I zoomed in on it so you guys could see it a little better. But notice there's only line 1 and neutral. There's no 220. We don't need it. It's got a regular plug. You can plug it in anywhere, but you have to have gas. You can have natural gas, you can have propane gas, either or. And we're going to talk about that as well. So this is the assembly. Let's take a look at the gas burner and break down the components. So this is the gas flow. The gas comes in through this pipe. Sometimes there's a shutoff located right here. In some dryers, there'll be a little hand valve to shut off the gas. So if I go to someone's house and I needed to replace the burner for any reason, this one here, the whole pipe is threaded into the burner, but on that one, there was a nut that you could unscrew and disconnect the pipe and remove the burner from that. This one doesn't have it. And that's why we don't have the shutoff here. So to work on this, you have to shut off the gas behind the dryer in the wall. Okay? So the gas comes in, it goes through this part here, goes through this valve, and comes out the burner. That's the direction. Let's take a look. What is this piece right here, this round piece? Just this part right here. Anybody know? ¿Cómo se llama? Regulator.
Yeah.
Okay? What a regulator does, how does it work?
Regular la entrada del agua del gas permanentemente a pesar de la diferencia de valores de fuera del.
Okay, so let me explain and simplify, and in English for those who don't understand Spanish. Listen, the regulator maintains pressure. Okay, the pressure coming in can go up or down depending on the house, for example. You have a gas dryer, a gas stove, a gas water heater, and maybe a gas furnace to heat the house. Okay? So I'm just using the dryer. The pressure coming to the dryer is going to be very high because it's the only appliance that's using that gas. But what would happen think of each appliance connected like a sprinkler to a hose. So I have the dryer running. What if I turn on the stove and I turn on 3 burners? Now the pressure on this side is going to drop. Well, the regulator is here, okay? And gas comes in through here and it goes up into this compartment and goes this way. It goes around here and then out. If the pressure is too high, this diaphragm, which is right here, will lift up from the gas pressure. But this piece is going to go up and it's going to close a little bit, not completely, but it can close completely as a safety. I went to a customer's house, had a gas stove, similar to the one on the table there, just a small 4-burner gas stove. The guy put it in the backyard and he wanted to cook fish. So he has a big propane tank for the whole house, but he ran a line to the stove outside, brand new, no burners, no gas at all. So I disconnect the line coming in, it's got gas. But it's, the first thing it hits is regulator. And the regulator controls the pressure coming out. So I check gas coming to the regulator and I have gas. Now I have 4 valves for the burners, but none of them are gases coming out. So I said, oh, regulator's bad. I need a new regulator because the valves over here, no gas coming out. I get a new regulator and put a new regulator on. Well, guess what? Still no gas. And I disconnected the regulator from the stove, connected gas, no gas coming out. I knew the regulator wasn't a gas out. What happened on propane tanks, there's a regulator on the tank. Because as you use the gas the tank, the volume in the tank is going to go down. The pressure is going to always be slightly different. It'll still be higher than what we need, but the pressure won't be as high. So the regulator's got to compensate. But what happened is the regulator on the tank was bad. So the full pressure of the tank was going to the stove, and the stove said, no, the pressure's too high, and this closed completely so no gas could come out.
As a safety.
As a safety. So this piece here is the regulator. And it's making sure that the pressure of the gas does not go up or down, it stays at a constant pressure. Okay? Like a stove, you got 4 burners, and you're cooking on one stove. Well, if I turn on 2 more, what would happen to this one? You would think it would go down. But no, the regulator opened up for more gas for the 3. And then when I close the other 2, this one doesn't go up because the regulator closed and maintain the pressure. That's its function. Okay? So we have to check regulator pressure. We'll get into that in a minute. I'm going to talk about conversion and gas pressure testing when I get to that. So gas comes into the regulator and the diaphragm goes up and down to maintain the pressure or the flow. So we have valve number 1 here. That's also the same as this one here. You can see how the gas is flowing and going around and coming out to the first valve, where we have 2 valves on this burner. Valve number 1 is here, valve number 2 is here, okay? So we have many ways to check gas pressure. We have WCP. Does anybody know what WCP stands for? Water, column, pressure. So I have many different examples of a meter that measures gas pressure, also known as a manometer. Some people call it manometer, but it's manometer. Now this is a big one. We don't need one this big, but it has measurements on here which are actual inches. If I took a ruler or tape measure, and each one of these numbers would represent an inch. So what happens is, You take the cap off and you put water in one side. As it goes down, it's gonna come back up the other side. Now the reason why it's this color is because this meter came with a little bit of food coloring dye that they put in the water so you could see it instead of clear water, but then it stains it, now it makes it hard to see. But anyways, you put the water so that it's zero on both sides. So when the water comes in, it's gonna come up the other side. When you have it even on zero, if it's a little bit higher or lower, look, you can slide this up or down to get that zero. Okay? So what happens is I connect this to the appliance on the stove or the dryer, and the pressure of the gas is going to push down one side and the other side is going to go up. And we have to measure, if I go down 3.5 inches here and I go up 3.5 inches here, what's the total? 7.
7.
So I have 7 inches. Okay? So on the dryer, never really showed many people this because most people don't really work on gas dryers, is there is a small little Allen key that goes on the back of this burner. This little screw here, okay? It goes on here like this. And it's normally there permanently. But you can take it off. And we take this little piece right here and we screw it onto the back of the burner. Now, if I take this off, gas is going to start leaking out. So we're going to shut off the gas before we do this. We're going to turn the gas on. The dryer is not plugged in. Okay, we're going to turn the gas on. Immediately the gas will come here through the regulator. We do not need electricity for this. It goes through the regulator to here, but the valves are not open. There's no power, so both valves are closed. The gas stopped right here. I get the first gas pressure reading, whatever the pressure is. Then I have to start the dryer. By starting the dryer, as the valves open, the pressure will drop some, but we don't want to see it drop too much. We want to see it maintain a specific pressure. This is if you have a problem where the burner's not lighting or the burner's going out or whatever. It's possible the regulator's bad and it's not maintaining the pressure to the burner. Okay, so this is how we check it. We just, can you hold this for a moment? Okay, so we got the burner here. So then what we would do is we would connect our manometer. I'm just going to sit right here. We're just going to connect the hose right to this like this, and we're going to use the clear hose because this hose is too big. We're going to connect the hose like this, and it'll give us our gas pressure reading. Okay, so this is a water column manometer. That means it measures pressure by water. Now this one is a little bit overkill because they don't make them much anymore. It's hard to find. So Amazon has this one. You notice it only has inches. It doesn't have the 2 columns like the other one. There's another tube inside this tube. I'll pass it around for you guys to see later. And that's where your hose would connect to, and it's going to push down and it's going to bring that number up. So you're going to add the 2. You're still going to add the 2 difference here. So this is the same as the other one, but much smaller. Now, could I just take a clear hose like this? Could I just take a clear hose like this and just take a ruler and do this? I mean, what, the hose just broke apart. No, seriously, the hose just came apart. Someone shoved the 2 hoses together. That's what happened. So, but could I take a hose and do this?
Yeah, I guess, yeah.
Yeah. I could just tape it to a ruler and measure the 2. I don't have to buy no fancy thing. That's inches of water column. So inches of water. That's what you're measuring. Okay? So just set it down somewhere. Not here. So we have 2 measurements. Natural gas and LP gas. Does anybody know what the measurements are supposed to be for natural?
3 to 5.
Someone study. 3, oh, let me undo this for a second. There we go. I don't know how to change the color. How do we fix this thing? There we go. There we go. So 3 to 5 inches for natural. Now, from the factory, Whirlpool or most manufacturers, both stoves and dryers, come already for natural gas. If the customer has natural gas, which is gas that comes in from the city, then all you do is connect the gas and you run it. Okay? That's 3 to 5 inches. What's LP? 7 to 11.
What's LP?
Liquid petroleum, or also what you would use for your barbecue grill, the tank.
Okay.
Customers may have a 100-pound up to a 300-pound tank in their home. Sometimes they may bury it in the ground and run the line, but most gas companies that provide gas to a customer's home is usually natural. So if you're in a neighborhood that has gas, some neighborhoods down here have gas, you'll find gas more up north, New York, Ohio, Pittsburgh, all those kinds of places. Gas is more prevalent. It's cheaper. Cheaper for a gas dryer, gas water heater, gas furnace, gas stove, because you're not using 240 volts electricity. Gas is not as expensive as electricity. Yes. So those are there. So we have other meters. We have a digital meter. I didn't bring my digital meter. It's in the cabinet, but that's okay. And then you have another analog meter. So I'll show you guys the analog one, but we also have that digital one. And this one here, basically, used to stay in there, that you do the same thing. You connect this, but this one only goes as high as 10 inches. Can you see that on the screen?
Yeah.
That only goes to 10 inches. So can I use this? Can I use this for LP gas?
No.
No. So you have to have one that will reach up to 15, 16 PSI or higher, so that when you're measuring the pressure is going to be able to read on the scale. This one only goes to 10, so it's only for natural. Okay? But when you guys get to gas appliances, I want you to do these tests. On the stove, it tells you how to do it. I didn't really have people do it on the dryer, but this is a special fitting here. This is, I looked it up, it's a 1/8 NTP, where it's threaded on one end and it's barbed on the other. This is like when you're in science class, you slide the hose on, the hose stays on.
And you need that to test the gas.
This is the only way you're going to connect your hose to the burner to test it on a dryer. On a stove, we do it in a different place. Well, let me see one thing. I think I have it up on the screen here. Here it is right here. 1/8 inch NTP male brass connector. It comes with this particular meter here, and you see this one does from what to what?
0 to 35 inches.
So is that gonna work for all of our gas?
Yes.
Yes. So this 1 meter is basically like the one I showed you in the blue one, but it's got the meter, but it also has the fitting that you need. And what do you think that fitting is for?
LP?
It's a reducer fitting. Like this one will fit in the burner, but what if what I want to attach it to has a bigger opening, probably 1/4. If this is 1/8, that's probably 1/4 inch. So it's threaded outside and inside. So you would screw that piece in and then screw the other piece into it. So this screws into that, and then that screws in to whatever you're testing. Remember, you could be doing commercial products that have gas, and you would need that type of device to test the gas pressure on there. So that right there is about $45, good price. It is important, if you're going to fix gas appliances, that you have this and know how to use this. Because sometimes the complaint from the customer is not the appliance, it's the gas pressure. Like I said, the stove I had wasn't working, and it was because the regulator was getting too much pressure. Okay? I went to one customer's house in Miami Beach, and he said, oh, the stove's not working, and he rents the property, right? So I'm like, oh, okay, I go, and it's just a little, thing is like 24 inches wide. It has 4 burners, but it's a little tiny thing, it's like small apartments, like efficiencies stuff, it's very little kitchen. So I go there and no gas is coming out. I don't know why, but there's a window right there. I look out the window and I see like the gas meters outside because he has natural gas. And I see a red tag on the meter. I said, your gas is turned off. He's like, what? Yeah, you're the owner. The gas was off. But I mean, what if I didn't see that? How do you tell a customer the gas is off? You put this meter and you say, look, there's no gas.
Good evening, parents. At this time, we should be transitioning into third period, which will begin promptly at 6:20.
Okay.
Should be transitioning
So
into third period.
here's another thing that we use this meter for. Customer calls you out and says, my appliance is leaking, I smell gas, it's leaking gas. I could connect this here, turn on the gas, get a reading, go behind the machine, shut the gas off. The pressure should stay. If the pressure starts dropping, my appliance is leaking. But you can't go to a customer and say, ma'am, I tested your dryer, it's not leaking. And, no, I smell it. Ma'am, look, I put the meter, it reads the pressure. I'm gonna turn off the gas here because if it's leaking, I turn it off, it's gonna drop. It's not dropping. It's not dropping. It's not leaking. Customer can't argue with that. It's not that customer is wrong, customer doesn't know what you know. And there's many times I've been trying to explain to a customer, this is how you use this product. I had one customer tell me, she was complaining about, she had cookies in the oven and some were burning and some were cooking. I says, well, one, you're using dark cookie sheets. You know that if you use dark cookie sheet versus like an aluminum shiny cookie sheet, it's actually different in baking. It actually gets hotter, black ones, it's the way they were. But not only that, but she had 2 trays, put one right over the other. So this one is blocking the heat from here, and this one's blocking the heat from here. We don't have even cooking. I said, you have to stagger them so that the air flow. Listen, I've been cooking since before you were born. Yeah, but I was trained on how this thing works. Do you know that? She finally accepted my answer, but you guys are gonna get customers like that. It's inevitable. So how do you explain to them? You have to think before you speak, okay, when you're talking to a customer. Because customers already, they don't know that much, but they know enough to say, that's not right. So you can't just say, no, it is right, and you're wrong. They're gonna be like, no, what are you talking about? You have to be able to explain it. If you can explain it where they understand it, they'll accept it. Okay? So, let's go back to the machine. So, we have a digital meter that will also do that same test and give you a display of how many inches of water column. Look at that, it's got the fitting on it too, right? Okay, so that's that. So let's continue with the flow of the gas through the machine. The gas flow comes in, goes through the regulator, it goes to valve number 1. When that valve opens, it goes to valve number 2. And when here, it goes out to the burner. Why 2 valves? Can't we just open with 1 valve and close with 1 valve? Why 2 valves?
Are they for different burners?
No, it's 1 burner. Here's the burner right here. The 2 valves are right here.
One for the start.
For safety, yes. And what if 1 valve stick and don't shut off? We have a second one that closes. There's no 100% fail safe, but there's more than that. I'll get into it again further down the road, but the 2 valves are there for safety. And we'll talk about how they operate. Okay? So after it goes to the 2 valves, it comes out the second valve and it hits something called the orifice. The word orifice just means hole or opening. You know, like there's a hole on this cart here, these are holes, these are orifices. The size of the orifice is important. The size for the gas, okay? We'll talk about that in a minute. So the orifice controls the pressure coming out. Look how big this is, and look how small the opening is. I mean, that's the dot that I just made is bigger than that hole. Okay? So that is what's controlling the gas coming out. And we'll talk about conversions in a minute. Okay? Now when it comes out here, you have an air shutter. Air is going to get pulled in with the gas. And right here, and we'll talk about it in the thing, it starts mixing the air with the gas. Like a torch, you have oxygen acetylene, you have to have the right setting on both. You have to have the right air shutter setting on this burner. If you look here, gas comes into the orifice, air is pulled in, they call it primary air, which is the very first air that comes in. The venturi is tapered because what's trying to do is just trying to mix the air and the gas together, like a blender. And as it comes through here, it comes out. Now it gets what they call secondary air, and it mixes with the air around the outside, and that's what goes into your dryer to heat your clothes. Okay, now we'll talk about the electrical part in a minute. So here's the conversion kit right here. This piece right here, really. The conversion kit, I don't know if this is tight or not. I need a flat screwdriver. So the conversion kit is, like I said, from the factory, this dryer comes set up for what?
Natural gas.
Natural gas. So the only time you would have to convert it is when the customer buys the dryer and they have LP. If they don't know and they are using the dryer, it's set up for natural, but they have LP, because LP is a higher pressure, the flame coming out here is going to be very yellow. It's going to cause black soot throughout the whole machine. So without shutting off the gas, you can take this regulator cap off. Now, that's a regulator cap. They are all different, and I'll go explain this to you in a minute. But you see this one here has two plastic pieces. What that does is it presses down on the diaphragm, not all the way, but because LP is a higher gas pressure, this pin will be right about here, and the gas pressure wants to push the diaphragm up, but it's going to hit this and not go up anymore. Because that regulator is set to control to have 3 to 5 inches of pressure, but I need 7 to 11 with LP. Okay? Now, the other thing is the orifices, as you can see here. The orifices are different sizes, aren't they?
Yeah.
Which one is LP?
The one on the right.
The large one or the small one?
Small one.
The small one,
Small one. Why the small one?
to minimize the
It's
pressure.
under higher pressure.
Yeah, because we got a higher pressure gas, we want to control the gas coming out with a smaller one. On stoves, it's the same thing. When we get a gas stove, comes set up for natural. We have to convert it. Sometimes we can just adjust the orifice to make it bigger or smaller, or we replace the orifice for more or less gas. Okay? Now I took this cap off, it didn't have the pin. On some dryers and stoves, you take this off and you flip it over and it pushes down. This one doesn't do that. Okay? So you have to have one with the plunger. This is natural, this is LP. So you have to have this. So you have to buy the conversion kit, change this cap, and the orifice is right in here inside this air shell. You see? You probably can't see it. I'll let you guys look at it after. I'll get it on the camera though, but the orifice is right in there. And it's really easier just to take this burner head off and you can get right to it. But see if we can get that on the camera, like right there. Can you see the orifice in there? Higher or lower?
Right, perfect.
Right there. It's that piece right in that opening. Be careful your hand, you're on the igniter.
Yeah.
Okay? So that's the orifice there. So if I hook this to LP, the flame's gonna be super big. And I gotta be careful. I can run it, but on some dryers, this funnel here, the flame is in the funnel. If we have an airflow problem or the flame's too big, some dryers put a safety right here, a limit thermal fuse or thermal cutoff they call it. It'll open, the burner won't work. And now they moved it on this dryer, it's all the way on the tube that goes behind the drum. But it's the same piece as there. That is this one in the diagram, I'll show it to you. View browsers. Oops. I just turned the menu off. Give me a second. This new software. I hit the wrong button. So where was I? Here, the diagram. So if you can see right here, thermal fuse not resettable. On the older machines, it was on this funnel. So if the customer had a ventilation issue in the house, what would happen to my flame? It wouldn't flow through here properly because the airflow would be reduced, the flame would be trapped in here. Okay, so that's the purpose of that piece would be here, but now they moved it higher up to the back of the drum on this other model. Why, I don't know, but that used to go bad a lot and then they had no heat, so that's what that is.
And is that showing a thermal fuse behind the drum?
Remember, diagrams don't show you physically where the part's located. They're only showing you that if that part fails, it's gonna affect that part.
Okay.
Okay? So, that's that. Let's go back to the slide we were on. Here. So, as you can see, this is a cap, just like the one I pulled out. We have to put one in with the pin if we're going to LP. But we also have to change the orifice. Okay? On some stoves, you have to change the orifice for every burner. Some you can adjust. Not all of them are adjustable orifices. And usually an adjustable orifice, it's got the square nut on it, so like this. And then a piece goes up. And the opening's there, but you can turn it with a wrench. And if you tighten it down, that's natural. If you open it up, I'm sorry, if you tighten it down,
It's LP.
it's LP. If you open it up, it's natural. Okay? But I'm not gonna go into that. It's on a gas stove, and I got a video already online about that one. A little bit about this gas dryer too, but let's move this out of the way. So anyways, that is the orifice kit that you would use to convert it. On the customer's owner's manual will give you the part number for the kit. Otherwise, you just Google it. All right, so let's talk about the electrical components and how the whole sequence is working and how those two valves work for safety. Now, this is the actual diagram that I showed you from the beginning, but this is out of the book, which is a little bit easier to understand. They're the same diagram, drawn differently. Okay, so let's talk about the one on top, and then we'll also compare it to the one on the bottom. So this is as soon as you apply power and press start on the dryer, this is where power is going to go. Power is going to come in, it's going to go through the hold coil, through the assist coil, and through the sensor, and through the igniter. Now, the hold coil and the assist coil are both where?
In valve one.
Valve number one. So remember I told you valve number one is the first one coming in, and that's valve number two. It looks like one piece, but there's 3 terminals on there. Okay? It looks like one solenoid, but we got 3 terminals. The other one's only got 2. Okay? That's got 2 terminals, got 3 terminals. This is called a split coil. In other words, there are 2 separate coils inside. On the older dryers, if you took this cover off, you'd actually see 2 separate pieces. And the real old ones didn't have a plug. They were all wired and wire nutted together. So each solenoid had two wires coming off and you had to wire them all together. If you disconnected them and you had to wire them back up, you're like, oh, which wire goes where? It was a pain. Okay?
4 pictures were a thing, huh?
Yep. We didn't have cell phones back then. So you have to go to customer's house. Can you imagine going to customer's house with a Polaroid, everything? And you're taking pictures and you're like this, and what are you doing? I need to see how to put your machine back together again. All right.
You have a dark room.
So the hold and assist coil are getting power immediately. Remember I said yesterday, when we press start, you're gonna hear tick. You're gonna hear,
The same time.
and that's that first valve energizing. Both solenoids are energizing. Now I bet nobody explained to me, why is there a hold and assist coil? Why didn't they just make one big coil?
Need both of them to open.
Yeah, but I can make one big one to open. Why do I have to have two separate ones?
Safety.
Because one hole will stay open.
But that's the function of it, but why put two separate solenoids instead of one big one that you energize is gonna hold the valve open? So let's go through the circuit. So the igniter and these two solenoids are the only three parts that are working. So these two are working, and this igniter here is working. Now this is like glass. If I was to hit it, I'd break it. And it's $40, $50 down the drain. So when you're taking the burner out, you're working on this, be very careful not to break this. Okay?
Which part are
So-
you referring to?
This graphite colored piece here with the shiny like metal on it, that's what's glowing red hot. We call that the igniter. It's a glow igniter. Ovens have the same thing, gas ovens. When you turn them on, you see them glowing. It doesn't look physically like this, but it's the same exact part.
Does the same thing.
Okay, so this is coming on, and the first valve is open. The gas has now moved to what?
Valve number 2.
To the second valve, and it's waiting. The gas came in to the first valve, and the second valve is waiting. Now, if we look here, you see the power goes through the hold coil and right out. Watch this. If I bring power in here, it goes right through the hold coil and right out. It doesn't go through any other parts in the burner. Same thing, right?
Right.
So I'm trying to show you that circuit's the same. They just drew it more complicated. Okay? They drew it that way, it'd be easy. So the other one, the assist coil, may or may not have this resistor, but then it goes through this sensor and out. That sensor is this sensor right here. Okay? They call it a flame sensor. It's incorrect. It's an igniter sensor. It's sensing the igniter. It's got a little window in there. Look. You see the little window in there? See the little window in there? See that window? So the heat from that sensor is going to open like a thermostat. Right now it's closed, right? So this assist coil, half of this coil has to go through this part. This is why we have two coils for safety. I'll get into that. Remember, two separate coils, one of the two have to go through this to work. Okay? So we'll come back to that in a minute.
So one of the coils is for the sensor.
I'm sorry?
So one of the coils is for the sensor.
No. The coil needs the sensor to be closed to work. The coil is not for the sensor. The sensor is to tell the dryer, hey, the igniter is working. I'm not going to let the gas out unless the igniter is working and hot enough to light the gas. Because as soon as the gas comes out, it's going to hit that igniter and light. But if it's not hot enough, that switch won't open. Valve number 2 won't work. So this is that switch here. When it's cold, it should be closed, 0 ohms, like a thermostat. When it's hot, it's open. It's like a thermostat. That's all it is. It's sensing this igniter. That funnel sits right here over the burner, and this sensor is right next to it. Inside the machine, okay? So our assist coil has to go through our sensor. So if we go here through our sensor, we go through this coil and out. If the sensor's open, where does the current gotta go? Through here to here. And if I put the two of them in series, I'm gonna take power away from that one. It's not going to work right. But right now, when I start up, this is how power goes. And then also power goes through here to my igniter. So this is as soon as you press start on the dryer, both solenoids are going to get power and the igniter. Both solenoids and the igniter are going to get power.
Good evening, parents. At this time, we should be transitioning to fourth period, which will begin promptly at 6:35. Thank you.
So that is to get gas from the first valve to here. Now we're waiting for the gas to go the rest of the way. So if we go here to the next screen, the sensor open. Now it's not open here, but power goes here, power here and here. These are parallel. What happens when we put two parts in parallel? What happens to the total resistance? All of you guys should have done that already by now.
It's
Does it go up or down?
down.
Down.
Down. When they're parallel, it drops. When they're in series, one to the other, they go up. We have both parallel and series circuits here, so we need to know that when that valve opens, this one is in series. Even though current is flowing through here, this one is going to prevent that one from getting full power. So hold and assist energize. Once it gets open, I don't need this one. It'd be like I say, hey, can you help me put this on the table? And the two of us lift something heavy and it's already resting on the table. I got it, I can do the rest. And that's what's happening here. We need both to open the valve, but once the valve is open, the other one can hold it by itself. So this one and this one. Now the igniter, it doesn't have as high a resistance as the coil. So the power here will go through valve number 2. So right now, these two are the only things energized. Even though power is going here, this one here is going to change the voltage to that part. So they're not going to be glowing red hot. The igniter is still hot enough physically to light the gas. So at that point, valve number 2 gets power and gas comes out and ignites. So let's look at this. This will open and then the power goes like this. Really, that's it. I mean, it also goes through here, but that's what's happening. Are you like, how do I fix it? I don't care about all this. How do I fix it? Listen, you have 3 coils. Yep, 3 pins on here. You can ohm them out. I can ohm out this one too, right? First thing a dryer comes on is the igniter wants to glow. That's what I want to see. I don't care about anything else. I want to see if this is glowing. If this doesn't glow, this could be bad. Because if we go back, I have to go through this sensor for the igniter to glow. So I don't see my igniter glowing. This could be a part that fails. So how do I prove it? I want to go right here with a meter, here and here, and see if I got 120 volts. Wherever the 2 wires coming into this whole burner assembly, I need to have 120. Here or here, 120 here. Red and blue. If I have 120, the problem's here. Coils, igniter, sensor. We can ohm this out like any other switch, right? We can ohm out the coils. We can ohm out the igniter. If I got voltage, we just check each one of those parts. But what happens is, power comes on, the valve number 1 opens up. This piece is allowing the igniter to glow. It's sensing the igniter is glowing, and once the igniter gets hot enough, it's going to click and then cycle. Okay? We're going to, once I'm done with the lecture, we're going to just apply voltage to this but we have to do a little bit of wiring, so we'll pause the video and then turn the video back on. But I want you guys to hear the different sounds and watch the cycling of the igniter, okay? So, we go back here, the flame sensor open, the gas lit, and it's lightning outside right now, right? You guys all heard the thunder. What if the power went off and back on, but the dryer kept running? Sometimes the turning of the dryer, the power goes off, but the drum is still causing it to rotate. We don't want the gas to come on, do we?
No.
So when the power shuts off, we lose power to the coils, the valve's gonna close. Now power come back on, but this sensor is saying, oh, the power just went off, it's hot. It's still hot from the flame. That's where the flame sensor comes in. It's hot for the flame, so that switch is open. So when that switch is open, this one gets power, no problem. But this one has to go through here. It never opens up valve number 1. So what happens is, it's forced to wait till this thing cools down, and it doesn't take very long. Forced to wait for it to cool down and close again. And then when this closes, then we give power here, and we start all over again. I'm sorry, that last one was not right. We go here and we go through the flame, so the igniter's going and valve number 1 opens and starts the whole cycle over again. Every time the thermostat in the dryer says we need heat or it's too hot and shut off, this burner has to go through that same cycle every time it lights up. But as a safety, this coil, that's the reason why they split the coil in half, is if the power goes off and comes back on, this coil won't get energy, the valve will never open. Any questions on that so far? Okay, pause the video. So, we're already in time dry. In the diagram, every switch for that burner is closed except for one. Which one is not closed right now?
One?
Which switch in the machine that tells that burner to come on is not closed right now?
Which one?
Nope.
Regulator?
Not the regulator, that's a mechanical part, electrical part. The centrifugal switch in the motor. In order for the burner to come on, 1M to 2M in the motor controls the heater or the gas dryer. So I'm not even gonna press start, I'm just gonna move the centrifugal switch, and you're going to hear this valve click. Okay, this is going to click. So valve number 1 is going to click. Let me see, it's not sitting right, but valve number 1 is going to click once I press on the centrifugal switch. This little black piece right here, I'm going to push on that. That's how we test the centrifugal switch. I'm going to push it like as if the motor's running, and that'll complete the circuit to my burner. Okay, so this is going to click. You're going to see the igniter glowing. After about 20 or 30 seconds, that's going to get hot enough to open up, and you're going to hear the second valve close. At that time, we would see the gas light, but we don't have the gas connected, okay? But listen for the click, click, and click, okay? It's hard to hear with the motor running, that's why I'm doing it this way. But if I just push on here, did you hear the click?
Yes.
Watch, the igniter starts to glow. See it glowing?
Yeah.
Now the flame sensor has to sense it. Listen for it to click. 3, 2, 1.
Yeah.
And you didn't hear it, but this one clicked also.
Yeah.
But watch, I turned it off. I do it again. My igniter's not glowing. You have to wait for that. Watch, that one's going to cool down, and then this valve's going to click again. Ready? So we got to wait for that sensor to cool down. The sensor's hot. But that's going to keep gas from coming out if the igniter's broken. Okay? I'm waiting. Take a while, huh? I'm pressing on it, so it's gotta go. Should be right about now. Let's see something. See how hot it is. Oh yeah, it's warm. But this piece here, it's not that hot. Let's see. Valve number 1 opened. You heard it click that time. So it cooled down just in time.
No.
That's heating up.
The cycles. Okay.
Yeah.
So that at that point gas would come out and the flame would light.
Yeah.
Okay? So in the older machines there'll be a plug right here. Line 1 in neutral, power coming into the whole assembly. The newer ones now, they change the wiring harness because why put a plastic plug here? Because it's more money. They just make the harness with one harness to the whole machine. It's cheaper. So remember, this is not controlling the temperature in the dryer. This is a safety not to let gas out. The thermostat on the back of the dryer is what controls the temperature, just like the electric dryer. Any questions? No? Okay. You can stop it.